This is the Dilution Lab video by Rachel, Jamie, Morgan, and Bailey. Here, Jamie is shown wearing proper lab attire, which consists of goggles, pants, and closed-toed shoes. The stock solution, which in this lab is sugar water, is a concentrated solution used in combination with the dilution, which is water in this lab, to create a diluted version of the stock solution. The meniscus is the curve in the upper surface of a liquid caused by surface tension between the liquid and the container. It is red at eye level at the bottom of the curve. This video shows that the meniscus in the volumetric flask sits directly on the mark in our experiment. Here, Jamie is properly reading her pipette by looking at it at eye level and looking at the bottom of the curve on the meniscus and recording it to the hundredths place. Here, we are properly weighing the beaker containing the stock solution and recording the mass to 3 decimal places so we can later subtract the empty beaker to know the mass of just the stock solution. Here, Rachel is using the volume concentration equation, which is C1V1 equals C2V2, to find the volume of sugar water needed to yield a concentration of 18% in the dilution. The concentration of the initial sugar solution is 20%, and the intended final concentration of the dilution is 18%. The volumetric flask holds 25 milliliters, thus the initial volume of the sugar solution must fit within the flask in addition to the water's volume. As you can see, the initial volume is 22.5 milliliters. The volume of water can be found by subtracting the initial volume of the sugar solution, which is 22.5 milliliters, from the final volume of the dilution, which is 25 milliliters. This will give you 2.5 milliliters. Here is another video showing proper use of the lab notebook. Here, Jamie is properly transferring the stock solution into a beaker for later pipetting. Here, Rachel is drawing 22.5 milliliters of the stock solution into her pipette, but not into the bulb. She continues to refill the pipette with the stock solution until the sum of the deposit equaled 22.5 milliliters. She puts the stock solution from the pipette into the 25 milliliter volumetric flask. Next, after washing the pipette, Rachel draws 2.5 milliliters of water into her pipette and puts it in the volumetric flask containing the stock solution. This results in a final concentration of 18%. We know this because of the C1V1 equals C2V2 formula.
Here we are properly transferring the sugar stock solution from the beaker into the graduated cylinder.
Here, Jamie is drawing 10 milliliters of water into her pipette to put in the volumetric flask, which already contains 15 milliliters of the stock solution. This creates a concentration of 12%. Here, Bailey draws up 16.25 milliliters of water into her pipette and puts it in the volumetric flask, which already has 8.75 milliliters of the stock solution. This creates a concentration of 7%. Here, Morgan draws up 20 milliliters of the stock solution into her pipette, but not into the bulb. She then adds it to the volumetric flask and later adds 5 milliliters of water to create a final concentration of 16%. After pouring the excess liquids down the sink, Bailey cleans the lab equipment with soap and water to be dried and put away. Here, Jamie is properly wiping down the countertops to leave a clean space for the next lab group.